Okay, hello everyone. I hope everyone is fine and healthy. Okay, so for ICSE student, that is grade 10 student, I will be explaining one chapter, that is circulatory system. We will be starting, and at the end of the chapter, there will be not end of the chapter, but yes, end of this video. See, it is not possible for me to complete one chapter in one video, so we will be doing it in parts. So at the end of every video, I'll be giving few questions to solve. You have to practice at home. And whatever doubts you have, you can ask me in comment section. I will try to solve that particular doubt in coming video. Okay, so let us begin with the chapter, that is circulatory system. Okay. So, okay. Now first, let us understand the components or simply needs. First, let us talk about the needs of circulatory system. Now, circulatory system, what is the need of circulatory system? Circulatory system, it is responsible for transporting, right? So, various substances has to be transported in our body, like digested food. Now, whatever food gets digested in our stomach and intestine, this food has to be transported to each and every part of the body. Each and every cell needs food, right? It also needs oxygen. So, this oxygen also has to be transported. Now, oxygen, we know we take in during breathing. So when we breathe in oxygen, which enters in lungs, and from lungs, that oxygen has to be transported to each and every part, right? Then other than this, excretory material has to be transported for excretion. Example, urea, which is produced in liver, it has to be transported to the kidney so that it can be eliminated from the body, right? Then other than this, hormones which are produced in one part of the body has to be transported to other part or all parts of the body. Example, growth hormone, which is produced in pituitary gland, has to be transported to different parts of the body, right? So that growth can occur. Now, this transportation of material in human being or in mammals is carried out by circulatory system. So let us first understand the components of circulatory system. What are the different components of circulatory system? So first thing, there is a need of medium which is going to act or which is going to transport substances. Now the medium is blood, right? One of the medium is blood. There are more fluid, but first the important fluid is blood. Other than this, now this particular fluid has to be transported via some vessel. So yes, second component is blood vessel. Third, now for transporting these or for fluid to flow in our body, there is a need of pumping organ. Yes, the pumping organ is heart. There are three components of circulatory system which we are going to focus on in this chapter. Those are blood vessel, and heart. So let us begin with blood. Let us understand blood first. Okay. Before that, let us discuss what are the different fluids which are responsible for transportation in our body. So the three principal fluids in our body which are responsible for transportation of substances are blood, tissue fluid, and lymph. Now, everyone knows about blood, right? So blood flows in arteries and veins, right? So when blood enters in this particular through arteries, it gets distributed in capillaries, and we have studied that capillaries have thin wall, right? Very thin wall. It is just made of single layer of cell. Now, from this particular or through this particular thin wall, what happens? Fluid part of the blood oozes out. It comes out, right? Containing glucose, oxygen, and other nutrients. It comes out. It oozes out from this capillary. So it comes out from these capillaries and enter in this intercellular space of cell, that is in tissue, right? And this fluid which enters in tissue is called as tissue fluid. So tissue fluid are the fluids which are present between in tissues, okay? And this particular tissue fluid is drained in another vessel. That vessel is lymph vessel. So this green color represents lymph vessel, okay? So tissue fluid enters in lymph vessel, and fluid which is flowing in lymph vessel is called as lymph. So these are the three principles. See, we are going to study about tissue fluid and lymph as well, but in later part of the chapter. First, we will understand about blood. Let us first begin with blood. Let us first discuss the properties of blood. What are the different properties of blood? Let us understand. So properties of blood, first, it is never stationary. It is in motion. It continuously moves from one part of the body to Another part, like an example, it moves from heart to different parts of the body, that is tissue, and back to heart through vessels, that is arteries and veins. Again, let us talk about the color. Now, color, it is red in color. Of course, it is red in color, but oxygenated blood as compared to deoxygenated blood, if we compare, oxygenated blood is bright red in color and deoxygenated blood is dark red in color. So have you ever thought why veins appear blue in color? Is it because blood is blue in color in veins? Of course not. Veins do appear blue in color, but that doesn't mean that blue color blood flows in it. Red color blood only flows, right? It appears blue in color because it has thin muscular wall and it is superficial. See, actually, arteries are also blue in color, but it is deeply situated, so we cannot observe it. Okay, we cannot see it. So that is just, we use blue color and red color for arteries and blue color for veins. That is just for representation purpose. There is nothing related to its actual color. Okay, now next, volume, blood. It is in average adult human approximately 5 to 6 liters of blood flows. If we talk about taste, it is saltish in taste. Everyone has sometime tasted blood when we get hurt in tongue or in mouth, right? So it is saltish in taste. Its pH. pH is slightly alkaline, that is more than 7. That is 7.3. Its range is 7.3 to 7.45 approximately. Now let us talk about the functions of blood. So those were the properties of blood. Okay. Now functions of blood. Two basic function of blood. One is transportation and second is protection. So first we will understand about transportation. Transportation of digested food. Digested food, like an example, glucose. That is carbohydrate. When it is digested in our stomach and intestine, it gets converted into glucose. Proteins gets converted into amino acids. Fats converted into fatty acids and glycerol. Okay, these digested food is absorbed by small intestine. These digested food enters in blood and it is transported by blood. Then oxygen, that is respiratory gas, we can say. Oxygen is transported from lungs to different part of the body, that is to tissue, in the form of oxyhaemoglobin. So basically, when we inhale, when oxygen enters in lungs, so in lungs, it gets converted. It combines with hemoglobin. Now, hemoglobin is the pigment, respiratory pigment present in red blood cell. So RBCs combine, in RBCs there is hemoglobin. Hemoglobin combines with oxygen and it forms compound, comparatively unstable compound, that is oxyhaemoglobin. And this oxyhaemoglobin transports oxygen to needy tissue where it gets broken. Oxyhemoglobin gets broken. Oxygen from oxyhemoglobin will be used by the tissue. Okay. And the carbon dioxide which is released, carbon dioxide is also transported, has to be transported. Now, carbon dioxide combines with hemoglobin to form carbaminohaemoglobin. So it is transported in the form of carbaminohaemoglobin. Okay. Most of the most of the carbon dioxide is transported in the form of bicarbonate. Some transported in the form of carbaminohaemoglobin. Then excretory material, which is produced in tissue, has to be transported to the organ from where it is released outside the body. Example, it has to be transported to the organ, like an example, skin, then lungs, then kidney, from where it is going to be released. Okay. Example, we have taken urea. So urea which is produced in liver has to be transported to kidney so that kidney eliminates it along with urine. Then comes distribution of hormones. We know hormones are produced in endocrine glands, and these hormones which are produced in endocrine glands has to be transported to other part of the body, and that transportation is also done by blood. Distribution of heat, one of the important function, it helps in distributing heat and thus maintains body temperature constant. Okay, it uniformly distributes the heat. Then, so these are the transportation. So various substances, there is digested for oxygen, carbon dioxide, excretory material, hormones, heat has to be transported. Then comes protection. Blood also provides protection. First by clotting. Whenever we get cut, do we know that blood does not flow continuously? At some point, flow of blood stops. We say blood clotting has taken place, right? So blood clots, forms a clot near the or at the injured area, right? so as to prevent excess loss of blood. What will happen if clot is not formed? Excess loss of blood will take place and it may lead to death. So it is providing protection by forming clot. Secondly, this clot. First, clot is preventing excess flow of blood. Second, this clot is covering that injured tissue and it prevents the entry of germs. This is how it provides protection. Second, WBC, white blood cells, which are present in blood, it provides immunity to our body. So any foreign material, bacteria, viruses, or any foreign material when enters in our body, it is engulfed by white blood cells. It is consumed by white blood cells and it provides protection. Third, WBCs are also responsible for producing antitoxin and antibody. Antitoxins are the type of antibody which neutralizes the toxins. Okay, so whatever toxin enters in our body or any toxins which are not formed in our body but enters in our body, it is formed by bacteria. Now these toxins has to be neutralized so as to provide protection, right? And that neutralization is done by antitoxin. Then antibodies also provide protection. WBC produces antibody against bacteria or any pathogen which has entered so as to kill it. So germs are killed by antibodies. This is how blood provides protection. Transpiration and protection. So these are the two important functions of blood. Okay, now let us talk about the components of blood. Composition of blood. Blood includes two important components, that is blood plasma, and second one is corpuscles. Corpuscles, that is blood cells. Okay, now if you talk about this is blood flowing in artery. It flows in arteries, veins, capillaries. Here we can see it is flowing in capillary. Now, the liquid part of the blood is called as plasma. Okay, and cellular elements. So two principal components are plasma and cellular elements. Okay, plasma, fluid part of the blood, and cellular elements, that is cells present in blood. Okay, present in this particular fluid part, that is plasma. Let us understand the composition of each, that is plasma and cellular elements. Now, plasma, it forms approximately 55 to 60% of blood. Okay, and out of this 55 to 60%, it includes 90 to 92% of water. It makes, or the plasma has 90 to 92% of water. Let's see what are the rest components. 7 to 8% of proteins. Proteins, like an example, heparin, and any other proteins which are present in this particular plasma. Transport, which is a protein which has to be transported. Okay, then 1% of inorganic salt, and inorganic salt mainly includes sodium chloride and sodium bicarbonate. Okay, the sodium bicarbonate is, yes, carbon dioxide. We have studied carbon dioxide. Most of the carbon dioxide is transported from tissue to lungs in the form of sodium bicarbonate. So this is sodium bicarbonate. Okay, then other substances are present in traces, small amount, which includes glucose, amino acids, hormone, urea, etc. Okay, so this is plasma. Then comes cellular element. The cellular element includes erythrocytes. Erythrocytes are red blood cells. Erythros means red. Cyte means cell. So erythrocyte, red blood cells. These are red blood cells. Leukocytes. Leuko means white. Cyte means cells. White blood cells. And thrombocytes. Thrombocytes includes platelets. Thrombocytes are also called as platelets. Okay, so these are platelets. So we are going to understand one by one each component of cellular element. Okay, plasma we have done. We are going to study about cellular element. Before this, let us understand one term, that is serum. Many a time question is asked, what is serum? So basically serum is plasma from which fibrinogen, protein fibrinogen has been removed. Okay, so plasma without fibrinogen is called as serum. Okay, yes. Now let us talk about erythrocyte, that is red blood cells. Red blood cells, erythros, red, cytes, cell. Okay, so red blood cells, also called as oxygen carriers, they are responsible for transporting oxygen. So let us understand about it. First, we'll discuss about structure. It's circular and biconcave. So you can see it is circular, shape is circular. Biconcave. Concave means depression. So basically concave. Okay, so depression. You can see side view of this red blood cell. Now you can see concavity on both the sides, upper side as well as lower side. Okay, so it is called as biconcave. So it is circular and biconcave. Diameter is approximately 7 micron, or it is even called 7 micrometer. 1 micron or 1 micrometer is equal to 10⁻³ millimeter. That means 1 millimeter, when if it is divided into 1,000 parts, the small unit which we get is called micron or micrometer, which is represented by mu. Okay, so this is the diameter. That means it is extremely small in size. You can imagine it is very small. So small and concave. Now let us understand the small size and concavity, how it is advantageous or how it is useful to our body. So small size and concavity which is present over here, it provides larger surface area. So it is concave on both the sides. So because of this concavity, surface area increases, and surface area increased surface area enables this red blood cell to absorb more oxygen and transport more oxygen. Okay. And then this small size enables it to travel through very fine capillaries. So it can travel to very fine capillary which is as thin as our hair strand. Okay, in a single file. In that capillary, this red blood cell is going to move in a single file. So small size help in traveling or helps this RBC to travel through capillaries. Now number, adult human male contains approximately, see we are all everything numbers. When we come to number, it is approximation. Adult human male contains approximately 5 million RBCs per millimeter cube. You can understand millimeter cube is we can say a single drop. So that particular single drop is going to contain 5 million RBC, 5 million red blood cell. Okay, and in adult female, in human adult female, number of RBC is comparatively less. That is 4.5 million red blood cells per millimeter cube. Now, this red blood cell contains hemoglobin. Hemoglobin, a respiratory pigment. Heme is iron, hemin is iron, and globin is globular protein, circular protein. Yes, hemoglobin, that is circular protein is present. Iron containing protein is present in this red blood cell, which does the work of transporting gases, that is oxygen from lung to different parts of the body, that is tissue, and carbon dioxide from tissues to lungs. Now, oxygen is transported, we have studied earlier as well. Oxygen is transported in the form of oxyhaemoglobin, which is unstable compound. So hemoglobin has affinity towards oxygen. It combines with oxygen in lungs and transport to the needy tissue in the form of oxyhaemoglobin, where it is going to get broken down. Oxygen is removed, oxygen enters in tissue, and the hemoglobin which is present, it takes carbon dioxide and transports this carbon dioxide from tissue to lungs in the form of carbaminohaemoglobin. Now, carbaminohaemoglobin is the complex of hemoglobin and carbon dioxide. Remember, carbaminohaemoglobin, hemoglobin, and carbon dioxide. Oxyhemoglobin, hemoglobin, and oxygen. Now, it has been observed that in poorly ventilated room, if fuel is burned, or simply if burning of fuel, if it takes place and if it is done in poorly ventilated room, it may lead to death of the person. Now let us understand why. Because now we have studied this in chemistry, that carbon monoxide is produced when fuel is burned in presence of insufficient oxygen. So if there is less oxygen in the room, since it is poorly ventilated, no free oxygen is going to enter, or exchange of gas is not very good. So oxygen level in the room decreases, right? And burning takes place in absence of oxygen or in insufficient supply of oxygen. And when fuel is burnt in insufficient supply of oxygen, carbon monoxide is produced. And this hemoglobin has very high affinity towards carbon monoxide. It readily combines with carbon monoxide. So it has carbon monoxide. When we inhale, carbon monoxide along with other components of air enters in lungs, and RBCs, red blood cells, and red blood cell hemoglobin is going to absorb this carbon monoxide rather than absorbing oxygen. So carbon monoxide absorbs carbon monoxide and forms a complex, strong complex carboxyhemoglobin. And this carboxyhemoglobin cut down the supply of oxygen. Oxygen supply reduces, oxygen is not getting transported to different parts of the body, and this may lead to, there is one question related to this, that there one give reason may be asked, like sleeping in poorly ventilated or sleeping near burning furnace in poorly ventilated room may lead to death. This is the reason. Okay. Now, let's talk about the life and death of RBCs. Where are these RBCs produced and where is it destroyed? Let us see. So in adults, RBCs are produced in red bone marrow. Now let us understand what is bone marrow. Now we know that bone is extremely hard, right? But inner part of the bone, this area, this inner part of the bone, this is soft. Okay, and this soft tissue is called as bone marrow. So this is the place where RBC, red blood cells, are produced. In fact, all blood cells are produced. Okay. Now in adults, it is produced in long bone marrows of ribs, breastbone. So ribs. So this is rib, breastbone. Breastbone is sternum. So it is produced in ribs and breastbone. Also, it is produced in ileum of hip girdle. We have studied about hip girdle, pelvic girdle, right? Lower part of the body has pelvic girdle or hip girdle. So in that hip girdle, this bone, okay, this bone, that is ileum. So in ileum also, red blood cells are produced. So in adult, RBCs are produced in long bone marrow of long bones, especially in ribs, breastbone, and ileum of hip girdle. Whereas in embryo, that is at embryonic stage, red blood cells are produced in liver and spleen. So liver, this organ we have come across many times. So this is liver, above stomach. And spleen. Spleen is lymphatic organ. It is a part of lymphatic system, lymphoid organ we call, which is present behind stomach and slightly above it. So this particular organ is called as spleen. We will understand spleen at the end of chapter in detail. Then in children, RBCs are produced in bone marrows of all bones up till the age of 5 years. Okay, so until 5 years, it is produced in all bone marrows, but as we grow, it is restricted to bone marrows of ribs, breastbone, and ileum. Then, mature red blood cells have no nucleus. There is no nucleus present. See, red blood cells are actually dead cells of our body. Okay. Red blood cells are dead cells. Okay, these are dead because their nucleus gets destroyed. See, initially when it is actually formed, the red blood cells do have nucleus, but when it gets matured, when red blood cell knows that it has to transport oxygen and carbon dioxide, what happens? Nucleus gets degenerated. Now, why is it so? Why do they use nucleus? So as to increase the surface area for transportation of gas. Okay, so mature RBCs do not have nucleus. That means these are dead. Okay, average lifespan. This lifespan, oh, these are already dead. Of course, these are dead. Dead cells cannot remain in our body as it is. Okay, for long. It has to be destroyed. It will get destroyed. So its average lifespan is about 120 days. So it gets destroyed within 120 days. Where is it destroyed? It is produced in red bone marrows. We have studied. Okay. After 120 days, it is going to get destroyed, and it is destroyed in spleen, liver, and bone marrow. Where, when red blood cells are destroyed, iron part is retained in the liver, okay, so that it can be used for further production of red blood cells, and the rest part is excreted along with feces in the form of bilirubin. Feces. Now, bilirubin is a bile pigment. Okay, we have studied about bile juice. Bile juice has bile pigment called as bilirubin. So this bilirubin enters along with bile juice in small intestine, and it becomes a part of feces and then thrown outside the body. It is ingested out of the body. Okay, so this is the life and death of RBCs. Then normal adult, approximately in human, 2 million RBCs are destroyed every second. And this makes about 1% of total erythrocytes in our body, right? So we can say that about every day, 1% of RBCs are destroyed. 1% RBCs are destroyed. See, if it is destroyed, of course, it is produced as well. So 1% of RBCs are produced as well. Now, see, normally number of red blood cell, it is found that number of red blood cell increases when we do physical exercises. Now, why during physical exercise? Because when we are doing physical exercises, need of oxygen by our muscle increases for producing more energy. So more oxygen has to be transported. For transporting more oxygen, more red blood cells are produced. Number of red blood cells are more during physical exercise. Number of red blood cell decreases, that is by 5% when we sleep. When we are sleeping, we are at rest. As compared to normally like now, when we sleep, when we compare these two actions, okay, when we sleep, demand for oxygen, demand for energy reduces, right? Body needs less energy. So less oxygen has to be transported. For this purpose, amount of red blood cells during sleep is found to be less. That is approximately 5% less. Okay. And it is also found that people living in hill region shows more number of RBCs. Now think why? Why people living in hill regions have more number of RBCs as compared to the normal person? Their number of RBC approximately increases by 30%. Yes. People living in hilly region, we know that hilly region, as we go up in atmosphere, level of oxygen decreases, right? So oxygen level is less, but this oxygen, need of oxygen by our body is more. So for efficient transport of oxygen, more red blood cells are required, and so they have more number of red blood cells. Okay. Now, when abnormally red blood cell increases abnormally, that is very number increases approximately more than, we can say, 5 billion, 10 billion, okay, 10 million, sorry, not billion, million. Now see what happens per millimeter cube. See, this particular condition is called as polycythemia. So polycythemia is the condition in which there is abnormal increase in red blood cell, and it is a type of blood cancer where bone marrow does not stop dividing, and red blood cells continuously are produced and produced and produced. Okay. Abnormally decrease in number of red blood cell is called as erythropenia. Erythros is erythrocytes, red blood cell, and penia means less. So if number of red blood cell decreases, that particular condition is called as erythropenia. Okay, so this is all about, not all about, okay, there is one more point. Red blood cell lacks nucleus, mitochondria, and endoplasmic reticulum. One of the important reasons. Red blood cells lack nucleus, mitochondria, and endoplasmic reticulum. Now why? We know that one of the major cell organelle, that is nucleus, is largest cell organelle of cell. It occupies large space, right? Now it lacks nucleus so that surface area can be increased. There is more space for transporting oxygen. It is not wasting its space. So nucleus is absent, so as to increase the space, and also size will reduce. If nucleus was present, red blood cell would not be concave, right? Circular, globular. So to avoid this, and if it is globular, it will not be able to transport through narrow capillaries. So lack of nucleus, first, it increases the surface area, volume ratio, okay, and secondly, it helps in transport of, or it helps in red blood cells to travel through narrow capillary. Okay. Second, loss of mitochondria. Okay, what is the work of mitochondria? Yes, mitochondria is responsible for production of energy. It is called powerhouse of the cell, right? Yes. Now, if RBCs have mitochondria, what will happen if RBCs have mitochondria? If RBCs have mitochondria, oxygen which it has to transport, it will use it for itself. So to prevent the usage of oxygen by itself, so that oxygen can be efficiently transported, they don't have any mitochondria. So they lack mitochondria so as to avoid usage of oxygen and glucose for themselves, so that they can be transported efficiently. Then comes endoplasmic reticulum. You know endoplasmic reticulum, it is present around nucleus. It forms supportive framework of the cell. Now, this absence of endoplasmic reticulum provides flexibility to red blood cells so that it can move through narrow capillaries. These are the reasons why they lack nucleus, mitochondria, and endoplasmic reticulum. So today we have studied about red blood cells. Okay, we started with the chapter. We studied about different fluids in our body, then properties of blood, then functions of blood. Okay, then composition of blood, and in composition we have completed till erythrocytes. We have completed erythrocytes. Now there are a few questions which you need to solve, and if you have any doubt, you're going to put in on comment section. Questions for homework are: give reason. Mammalian RBCs lack nucleus, mitochondria, and endoplasmic reticulum, which we just now did. Okay, and second, sleeping near burning furnace in poorly ventilated room may cause death. Okay, so I hope you understood. Let me know your view and any doubt if you have in comment section. Thank you very much.